Most people assume the pyramids took so long because moving each block was backbreaking work. The math says otherwise. At the Great Pyramid's peak, workers spent 7 hours per block just waiting for levers. Not cutting stone, not dragging it across the desert, just standing around while a team of men inched one block upward using wooden poles. The Great Pyramid of Khufu is the oldest of the 7 wonders of the ancient world, and the only one still standing. For thousands of years, it has remained an enigma to engineers, archaeologists, and anyone who tries to imagine assembling 2.3 million blocks without cranes. The real mystery isn't whether humans built it, but how they possibly had the patience to do so. In 5 minutes, you'll understand why the pyramid's construction was less about brute strength and more about organizing the world's slowest assembly line. The Great Pyramid of Khufu sits in Giza as the sole survivor of the 7 wonders, a monument so old it was already ancient when Herodotus visited in the 5th century BC. By the time the Greeks started making lists of impressive architecture, the pyramid had been standing for over 2,000 years. It's outlasted empires, religions, entire civilizations, and every other wonder on that famous list. The Hanging Gardens are gone. The Colossus of Rhodes toppled. The Lighthouse of Alexandria crumbled into the Mediterranean. Meanwhile, Khufu's pyramid sits there like a particularly smug geometric uncle at a family reunion, reminding everyone it's seen things. What makes it remarkable isn't just its survival, but the fact that we still argue about how it was built. Engineers have sufficiently answered questions about the pyramid's dimensions, alignment, and internal chambers. The debate that never ceased concerns one deceptively simple problem. How did they move and place the stones? Not whether they could, because obviously they did, but how they organized the process without losing their collective minds. Ancient historians like Diodorus Siculus noted that the whole complex looked as if some god had set it down entire upon the sand. That's poetic, but also a tacit admission that even 1,000 years later, nobody could quite explain the logistics. The technical answer exists in well-established scientific facts, but those facts reveal a process so tedious it borders on the absurd. Let's talk about scale, because the Great Pyramid is where human ambition met mathematical cruelty. The structure contains approximately 2.3 million limestone blocks. The average limestone block weighs up to 15 tons, which is roughly the weight of 2 full-grown African elephants, except less cooperative and significantly harder to convince to move uphill. Then there are the granite monoliths in the interior chambers, some weighing up to 70 tons. That's the weight of about 10 modern cars stacked together, carved from a quarry and somehow transported to the construction site. To put this in perspective, if you placed one block every 5 minutes, working 24 hours a day without breaks, it would take over 21 years just to position them all. The pyramid was likely built in about 20 to 30 years, which means the actual pace was closer to 1 block every 2 to 3 minutes during active construction seasons. You need foremen tracking which blocks go where. You need supply chains coordinating quarries miles away. You need workers who don't trip over each other or accidentally send a 15-ton block sliding into someone's lunch area. The organizational complexity required wasn't just impressive. It was borderline obsessive. Modern construction projects use computer modeling, project management software, and safety regulations, and they still run behind schedule. The Egyptians did this with copper tools, rope, and presumably a lot of very intense meetings. But before you can place 2.3 million blocks, you need to carve them out of solid rock, which brings us to the part where patience becomes a survival skill. The blocks came from quarries, carved using copper tools. Copper. Not steel, not diamond-tipped saws, copper, a metal so soft you can bend it with moderate enthusiasm. Ancient Egyptian workers used copper chisels, saws, and drilling tools to slice through limestone and granite mountains. The process involved hammering copper tools into the stone, often with the help of wooden wedges soaked in water that expanded to crack the rock. It sounds implausible until you realize that modern researchers actually tested this method. A team successfully carved and shaped a 2.5-ton limestone block using replica copper tools, demonstrating that the construction of the Great Pyramid was technically achievable. The experiment also demonstrated that it was monumentally, soul-crushingly tedious. Carving one block took days of repetitive hammering, sawing, and leveraging. Multiply that by 2.3 million blocks, and you begin to understand why pyramid construction was a multi-generational national project. The copper tools wore out constantly, requiring frequent replacement and resharpening. Quarry workers weren't just laborers. They were skilled craftsmen who understood stone grain, fracture points, and how to avoid turning a 15-ton block into 15 tons of rubble. The quarries themselves were located near the construction site for limestone, but some materials, particularly granite, came from Aswan, over 800 kilometers away. Diodorus Siculus mentioned stone transported from Arabia, suggesting supply chains that stretched across regions. Every block represented hours of careful cutting, and every mistake meant starting over. The margin for error was essentially zero, because nobody wanted to explain to the pharaoh why they had just destroyed a week's worth of work. Once carved, the blocks had to be transported from the quarries to the construction site, and this is where things got really interesting from a logistics standpoint. The blocks were dragged. Workers used sledges, ropes, and lubrication techniques, possibly wetting the sand to reduce friction, a method confirmed by tomb paintings showing water being poured in front of sledges. The cornerstone method was used during construction, which involved setting a single stone as a reference point to ensure alignment and precision. This wasn't just about brute force. It was about maintaining geometric accuracy across a structure that would eventually rise over 140 meters. Every block had to fit precisely, or the entire pyramid would become an expensive pile of rocks with delusions of grandeur. Some blocks traveled considerable distances. Granite from Aswan likely came by river during the Nile's flood season, when water levels allowed boats to carry unimaginable weight. Once at Giza, the blocks were dragged from the delivery point to the pyramid base using teams of workers, possibly dozens of men per block, depending on its weight. The process required coordination that would make modern supply chain managers weep. You had to time quarry output with river transport schedules, then coordinate ground crews to drag blocks to precise locations without causing a massive traffic jam of stone. Imagine a construction site where every delivery truck weighs 15 tons, has no brakes, and is pulled by sweaty humans who would really like a lunch break. The fact that this worked at all is remarkable. The fact that it worked efficiently enough to complete the pyramid in decades is borderline miraculous. Getting the blocks to the site was only half the battle, though. The real patience test came when they tried to lift them into place. Here is where the pyramid construction becomes less about strength and more about the kind of patience that borders on meditation. For the levering technique described by researcher Hodges, the average time to elevate a single block at the higher levels of construction works out to about 7 hours. 7 hours per block. Not cutting it, not transporting it, just lifting it from one level to the next using wooden levers, ramps, and incremental hoisting. Picture the scene. A team of workers stands around a 15-ton limestone block with wooden poles, lifting one edge a few inches, sliding a support underneath, then repeating the process on the other side. Inch by inch, hour by hour, the block rises. It's the world's slowest game of Jenga, except if you lose, someone gets crushed. At the pyramid's base, lifting blocks was relatively straightforward because the height was manageable. But as the pyramid grew taller, each lift took longer, required more coordination, and offered more opportunities for catastrophic failure. The workforce had to be rotated constantly because no human can lever a 15-ton block for 7 straight hours without their arms filing a formal complaint. This means the pyramid wasn't just a construction project. It was a massive exercise in human resource management. Workers needed food, water, rest, and rotation schedules. They needed supervisors who could identify when someone was about to drop a lever and flatten a coworker. The sheer organizational overhead required to keep this process running smoothly, day after day, for decades is staggering. And yet, they did it. They placed over 2 million blocks, many of them at heights that required hours of levering. And the pyramid still stands as a geometrically precise monument to the power of incremental effort, and probably a lot of motivational speeches. Ancient historians like Diodorus Siculus mentioned that the edifices were raised utilizing earthen ramps, since machines for lifting had not yet been invented in those days. The ramp theory makes intuitive sense. Build a long sloping ramp alongside the pyramid, drag the blocks up the incline, and gradually raise the ramp as the pyramid grows taller. Simple, logical, and supported by historical accounts. There's just one small problem. No trace remains of either ramps or the dressing of the stones. Diodorus himself found this puzzling, noting that it seemed as if the whole complex were set down entire upon the surrounding sand by some god. Archaeologists have searched for evidence of massive external ramps and found essentially nothing. The sand has swallowed any trace, or the ramps were dismantled so thoroughly that no remnant survived. This has led to competing theories: external straight ramps, external spiral ramps, internal ramps built within the pyramid structure itself, or some combination of methods. Each theory has engineering merit and archaeological gaps. An external straight ramp long enough to reach the pyramid's peak would need to be over 1 kilometer long and contain more material than the pyramid itself. A spiral ramp makes more sense volumetrically but creates corner-turning problems for massive blocks. Internal ramps are elegant but require building the ramp and the pyramid simultaneously, which is a logistical headache. The truth is probably some hybrid approach that evolved during construction, using different methods for different stages. What's certain is that the Egyptians built the thing. The ramps existed in some form, and then they vanished so completely that we're still arguing about them thousands of years later. Here's a detail that puts the Great Pyramid in perspective. Construction techniques used seem to have developed over time, and later pyramids were not constructed in the same way as earlier ones. The Great Pyramid represents peak pyramid ambition, the moment when Egyptian architects looked at the desert and thought, "Let's build the biggest, most precisely aligned monument physically possible with copper tools and human stubbornness." And they did it. But then something interesting happened. Later pyramids got smaller, used less stone, employed different construction techniques, and generally suggested that subsequent pharaohs took one look at the Khufu project timeline and said, "Let's not do that again." The pyramids that followed were still impressive, but they incorporated lessons learned, often using smaller blocks, less ambitious dimensions, and construction shortcuts that earlier builders would have considered cheating. Some later pyramids even used mud brick cores with limestone casings, a practical approach that saved decades of labor. It's as if the Egyptians collectively realized that proving you could build a geometric mountain was sufficient, and future generations didn't need to repeat the exercise just to make a point. The Great Pyramid became the benchmark, the monument that said we did this once, and that's enough. Its construction represented the culmination of pyramid building evolution, after which Egyptian architects said, "We've peaked. Let's try something different." The legacy wasn't just the structure itself, but the techniques refined during its construction. Organizational systems, workforce management, precision quarrying, and the kind of patience that modern civilization has largely forgotten. The Great Pyramid wasn't built by aliens, lost technology, or mystical powers. It was built by humans with copper tools, wooden levers, and a level of organizational patience that makes modern project management look like chaos. The real wonder isn't the engineering, though that's impressive. The real wonder is that thousands of workers spent decades lifting blocks inch by inch, 7 hours at a time, without modern machinery or the ability to check the progress bar. They coordinated supply chains across hundreds of kilometers, placed over 2 million blocks with geometric precision, and then dismantled the ramps so thoroughly we're still guessing how they work. The pyramid stands as a monument, not just to a pharaoh, but to incremental effort, the kind of slow, deliberate construction that modern culture has almost entirely abandoned. Next time you get impatient waiting for a download or a delivery, remember that somewhere in ancient Egypt, a team of workers spent 7 hours lifting one block. and they did it 2 million times.